When you shuffle a deck of cards, you're creating a unique sequence that has likely never existed before in the history of the universe. To calculate the number of possible ways to arrange these cards, we use a factorial. For the first card to choose, you have 52 options. For the second, 51, then 50, then 49, all the way down to 1. That's 52 factorial. The exclamation mark means multiply every number from 52 down to 1, which in expanded form equals this incredibly large number, being 68 digits long. However, this is nothing compared to the number of possibilities of chess games. At the start, there are 32 pieces, but only 10 pieces can move. It can move the 8 pawns or the 2 knights, while making up 20 possible decisions, 4 knight moves, or 16 pawn movements by either going up 1 square or up 2 squares. But after black responds, there are already 400 possible games. And on 2 moves, white's possibilities jumps to 9,000, and black's jumps to 200,000 possible games. If we graph out the moves versus the possibilities, we get this graph. In the first moves of chess, not much is happening, but once your pieces get freedom, it goes vertical, and the possibilities speed up immediately. In the 1950s, Claude Shannon, a pioneer of information theory, tried to estimate the total number of possible chess games in the first 40 moves. He landed on 10 to the 120. For reference, the number of atoms in the observable universe is 10 to the 80. That's 40 more zeros in a number than there are atoms. Even if every atom in the universe was its own universe and we count all those atoms, we still need to go one layer deeper to represent every possible 60-move chess game. Alright, last time I say this, but it's still nothing compared to Graham's number. This next number is not just big, it's a number so large that if you tried to store every digit in your brain, your head would collapse into a black hole before you got close. This is Graham's number. Before we can talk about this new number, we need to learn a new notation. Let's start simple. 3 to the power of 3 equals 27. We write this as 3 up arrow 3. One arrow just means regular exponentation. Now, what happens with 2 arrows? 3 up up 3. This is called tetration or repeated exponentation. It means 3 to the power of 3 to the power of 3. That's 3 to the 27, which equals 7 trillion. 3 arrows is called pentation. It expands into 3 double arrow 3 double arrow 3, which chains tetrations together. The right side evaluates first, giving us that 7 trillion number from before, and then we build a tower of 3s that many levels tall. Now in this case, even if every atom in the observable universe were a pen, writing a digit per second, the universe would end before you finish writing the number of digits in this number, and we only have 3 arrows. Now we have 3 4 arrow 3, which expands into 3 triple arrowing itself using that insane pentation result as the input. We call this G1. G1 is so large that it makes the 3 arrow number look like 0 by comparison. Ultimately, this number came from a real math problem involving Ramsey theory, a branch of combinatorics that asks how large a structure must be to guarantee some kind of order or pattern always appears. The core idea is that complete disorder is impossible. Given enough elements, some order must come. Here's the problem that actually produced this number. Imagine a party with n people. From those people, form every possible subset. Within each subset, pair up every 2 people. Now color every pair either red or blue. The question is, how many people do you need to guarantee that you can always find 4 subsets where every person appears in an even number and every pair among them share the same color? The smallest answer is 6, and the largest known upper bound? That's Graham's number. So here's how we build it. G1 is 3 with 4 arrows, G2 is 3 with G1 arrows, and G3 is 3 with G2 arrows. Each layer uses the previous number as the arrow count for the next. We do this 64 times till we get to Graham's number, G64. 64 layers of incomprehensible arrows, a number so large it cannot exist physically anywhere in the universe. It cannot be written, it cannot be stored, it cannot be imagined, it exists only as logic.